Okay, and for our fourth video, we're going to focus on assessing variance. So it's an easy test to do. We're going to talk about the Ftest here in a second, and it's an important test to do for us to understand which t-test we should use. And if we're in a hurry, we can just assume unequal variance. But if you've got the time to do it, it's a pretty easy one to do. Now, when we're doing the correct t-test, we should first evaluate our data with respect to those columns, with respect to, are they normally distributed? Assuming that they are, then you would also be interested in assessing their variance. So should we do the t-test for unequal variance or the t-test for equal variance? So answering that question is very easy to do once we do the test for equal variance. So the Ftest is what that is called. So how do we interpret an Ftest result? Well, generally the higher the p-value is, the more similar the data are with respect to variance. Low p-values, whenever the p-value is less than 0.05, we assume that there is a significant difference between two groups. So some people will assign feelings to p-values. They'll say that, oh, a p-value less than 0.05, that's what we want. There are no feelings involved in p-values. P-values are primarily used for determining whether or not there's a significant difference between two groups. In order to understand how to interpret the p-value, you have to understand what you're testing the difference between two groups for. So in this case, we're looking at, is there a difference in the variance of one group versus another? Low p-values mean that there is a difference between two groups. High p-values mean that we have insufficient evidence to conclude that there's a difference between the two groups. Now, how do we do it? In Excel, we've got the Ftest as one of our data analysis options. So the Ftest 2 sample for variances. We would then highlight our age column or our continuous variable column number 1 and then compare it against another column, continuous variable column number 2, whatever it might be. So this is age of that one group versus the age of the other group. So the age of the ever e-cigarette users versus the age of the non-e-cigarette users. We need to click labels if our columns are labeled at the top. Then we tell it to run. And when we do, it creates some data here for us. And in this case, the p-value, it just reports it as 0, which is problematic. A less than sign or something would be helpful, or some decimal, would have been beneficial. But there is such a difference in these variances. The variance of this group is 6.25. The variance in this group is 13.83. So major difference between these two groups. So that major difference, when we look at the p-value, I went in there and changed the format of that cell to like 20 zeros, and it's still that low. So we would report that as p is less than, say, 0.001. We do not report it as equals 0. P does not equal 0. At some point, there's some probability that, and it might be slim, so we would just say p less than 0.001 would probably be sufficient. So that pretty much concludes that part of it. Now, how would you interpret these results? Well, since the p-value is clearly less than 0.05, we would assume that the variances are different. So we would call this unequal variance. The alternative is to assume equal variance, which we're not going to do. So we have to assume unequal variance, and when we do our t-test, had the data met the normal distribution, we would then do the t-test for unequal variance. There is, in many cases, a tendency on my part where I find the data that are the most non-parametric also seem to be the ones that also have the most amount of unequal variance. That may not be true, but that's just what I've encountered with environmental data and health data related to environmental factors. So if you have any questions or comments, you can always contact me at any time. I'm going to run through a sample here in the event that that wasn't clear. I'm going to go to the Excel sheet here and pull it up and we'll run through this. So I've got the age group here. Here's the ever use e-cigarette group. This is the never. So we'll have it be this group here. So that's the E column. So that's the ever. And then over here we've got ever used that group. So they've ever used it. So there's their age. They're the AH column. So we're going to go to Tools, Data Analysis, Ftest. So I'm going to highlight, I'm going to do it backwards from the way I did it earlier. So I'm going to highlight the ever use e-cigarette. So these are the never. They're 0. 1 being yes, 0 being no. I'm going to highlight them. So I've highlighted them. Now I have to go to variable 2 range. So I go to the continuous variable I'm interested in here, right there, AH. That's it. There, the ages are highlighted. The E column versus the AH column. I can change this if I wanted to, the Ftest. If you wanted to use a 0.10, you could, but we're going to use the 0.05. And I'm going to tell it to go. So it runs, and here we go. And it actually gave me a p-value here. Instead of it saying 0, it actually gave me the p-value here. And it's like 0.0000 going out like 17 decimals. So it's I can format this cell and we'll go out to like 19 decimals. You know, but anyways, you can see it's when it's like 10 to the or 1.7 to the times 10 to the negative 17th, you know it's a really small number. So it's like 0.000017. So clearly the p-value is less than 0.05. So in this case, if we would assume that there's unequal variance between these two groups. So that's all for this section. Again, if you are not this section, but this Ftest video. So we're going to do the t-testing here in a second. So that finishes up this particular video. All right, thank you.